See, so the Broglie suggested this thing, the particle can behave as a wave, but it was just hypothesis. Okay, but calculation suggested this thing. Say, with the help of analogous with the X-ray diffraction of the crystal, one can verify this thing whether this happens or not. So scientists Devisson and Garmer performed one experiment related to this phenomenon. This one is the experimental arrangement in which the electron gun was taken and it was here connected with low tension potential difference. So with the help of this particular low tension potential difference, the cathode in the electron gun was heated, which emit the electrons. Here the cathode was coated with barium oxide, so it can emit the electrons at low tension. And then here the electron gun was connected with high tension, means high potential difference, and another cylinder was placed against it with two holes on the axis of it, so that when these electrons emitted from the electron gun enter to this particular cylinder, then due to this high tension potential difference will be accelerated, as well as the well confined collimated beam of the electron will be prepared. And then after that particular collimated electron beam was incidented on the nickel crystal. And then after the diffraction of it, or we can say scattering of it at different angles was measured. So there was a movable detector, or we can say collector, which one was connected with galvanometer, and that particular detector can be moved on the circular scale. So when we place it at different positions, then with the help of the measurement of the current in the galvanometer, one can measure the intensity of the scattered electrons at different angles. This type of experiment was performed by Devisson and Garmer. This entire arrangement was placed in the evacuated chamber, right? So when the electrons are scattered, their interaction with any other particle not possible. Okay. See, then in this particular experiment, the observations were taken for different accelerating voltage starting from 44 volt to 68 volt. And for each accelerating voltage, they measured the intensity of the scattering beam at different angle. એટલે કે સપોઝ પહેલા આપણે 44 વોલ્ટ એક્સેલરેટિંગ વોલ્ટેજ રાખ્યા અને ઇલેક્ટ્રોનને નિકલ ક્રિસ્ટલ ઉપર ઇન્સિડેન્ટ કર્યા, ત્યાંથી એ સ્કેટર્ડ થયા. હવે માનો કે આપણે ડિટેક્ટરને at the scattering angle 10 degree, scattering angle, that is the angle between the direction of the incident beam and the scattered beam. Okay, તો 10 ડિગ્રીએ આપણે રાખ્યું અને કરંટ મેઝર કર્યો, કારણ કે ઇલેક્ટ્રોન આવ્યા એને આપણે ડિટેક્ટરથી અથવા તો કલેક્ટરથી કલેક્ટ કરી અને ગેલ્વેનોમીટરમાંથી પાસ કર્યા, એટલે કરંટ મેઝર થશે. ઓકે, પછી આપણે એને મૂકીએ 20 ડિગ્રીએ, 30 ડિગ્રીએ, 40 ડિગ્રીએ, 50 ડિગ્રીએ, લાઈક ધેટ. પછી 44 ની જગ્યાએ આપણે 46 વોલ્ટ રાખીએ એક્સેલરેટિંગ વોલ્ટેજ અને આખો એક્સપેરિમેન્ટ પછી રિપીટ કરીએ, લાઈક ધેટ the observations were taken. Then see the important thing now in the result. it was noticed that a strong peak appear in the intensity of the scattered electron for an accelerating voltage of 54 volt at a scattering angle of 50 degree. Clear? Now see, now from the electron diffraction measurement, the wavelength measured for that diffracted beam, that was of the order of 0.165 nanometer. And now if we substitute the value of the voltage 54 volt in the equation of the Broglie wavelength lambda equal to h by p, later on we derived this one as 1.227 upon root V nanometer. So in this equation, if we substitute here V equal to 54, then your answer that will be very close to this 0.165 meter. So scattering of electron was exactly like the diffraction of X-rays. And then with the help of this experiment, it was confirmed, yes, particle have the wave nature. So in certain favorable conditions or circumstances, particle also behave as a wave. So then after the duality of wave and particle was established and all accepted this thing, in nature there is the duality. Clear?